Okay, good morning. This is Friday morning. We are recording this lecture for all our lost seniors who are on retreat. Hope they don't get swamped. This is the quiz that you're going to have on Monday. This is the quiz. This is an all or none quiz. I think I can write on here. Okay, so this is an all or none quiz. You have two questions. The first question is write the limit definition of a function, evaluate at a point where x is c, start your definition with this. So you have to write that. Note that this is a limit, so you have to write limit. I'm going to give you the answers. You have to memorize it. You have to do this on Monday, right? So everybody will have this available. You're going to write, whoops, I guess we better follow the directions. We're going to write f prime of c equals a limit as x goes to c, x minus c on the bottom, and f of x minus f of c. That's the first one answered. The second one says, write the limit definition for the function f evaluated at any point x, use h for horizontal increment, and start your definition with. So f prime of x is a limit as h goes to 0. H here, f of x plus h here, take away f of x. You write those two things down, you get an A+. If anything is wrong, you get an F. Okay, so this is an all or none quiz. Everything has to be exactly right. You're going to write it in on Monday, and you turn it in, and you get your A+, and everybody's happy. If you leave one thing off, for example, if you were to not put the prime here and you wrote this, the whole thing is F. The whole thing's wrong. Everybody clear with that? Now, instead of just memorizing what's going on, what I want to do is I want to try to give you a sense of why this is so obvious. So I'm going to draw a graph of a function, and we're going to try to consider the tangent line right here. So we know this is a point in the domain C. Here's x. Here's y. Y is f of x. And we want to find the slope of this tangent line. Okay, so the way derivatives come about is we start with the slope of a secant line. So we find this slope first, m secant. Now, as you recall, that's not calculus. That's just plain old algebra 1. You're trying to find the slope of a line given these 2 points. So let me draw a little triangle here. This is the run, and this is the rise. And you know m sec is the change in the y-coordinate divided by the change in the x-coordinate. So again, no calculus here. This is just plain old arithmetic. We should have the ordered pairs that fit here. So let me put the ordered pairs in. If this is C on the axis, we would go over here and say this is f of C. So the ordered pair right there is the ordered pair C comma f of C. Okay? Now how about this other point? Well, I haven't specified the coordinates for this other point. So let me just call this guy x. This is an unknown x. This, notice, is fixed. That's not going anywhere. X is the one that's going to be changing. And we need the ordered pair that fits for this guy. Well, let's see. Y is f of x. So f of x is the y-coordinate right here. And the ordered pair for this guy would be x comma f of x. So that seems a little strange, but let's keep that just for a second. Now, let's figure out the change in the y. You know how to do change in y. You take the big Y and you subtract off the little y. So the top here is going to be f of x, take away f of c. And the change in the x down here, it's going to be this x, take away that x. So that's simply x minus c. There's our difference quotient, slope of the secant line. Now what we want to do is we think, well, if this x gets really close to c, then this point will travel along the curve, and the secant line gets closer and closer and closer to the tangent line. And when x actually jumps right on top of c, then you have, in fact, the tangent line, which is what we're looking for. So the slope of the tangent line, m tan, is in fact the limit of this thing right here. So you just write that down, f of x minus f of c all over x minus c, but we're taking the limit as x gets close to c. X gets close to c. Okay, so that's the slope of the tangent line, and if we go back to our little quiz, that was this right here. Okay, so f prime of c is the limit as x goes to c, f of x minus f of c over x minus c. These are two y coordinates up top, and these are the x coordinates on the bottom, and x is getting close to the number c. Okay, so hopefully by knowing what the picture looks like, the formula that you're going to memorize makes sense. Okay, how about the other formula? It's a very similar idea, except now we are not going to have a specific value c. We're going to have sort of an arbitrary value c. The picture looks like this. Okay, so here's our curve again. This is some unknown x. We're trying to find the slope of the tangent line at x. Okay, so once again, we're going to need two ordered pairs, and we're going to do a limit. This one now, the ordered pair is x f of x. Suppose I can put that in right there. Ordered pair x comma f of x. Okay, now we need to have another point nearby. So what we're going to do is we're going to go a horizontal distance. I'm going to call it h in this case. You can also call it delta x, but I'm going to call it h for the horizontal increment. If this is x and this horizontal increment is h, this has got to be x plus h. That's that. And we go up to the curve, and we have a point there. So we have an ordered pair. The x coordinate is this one, x plus h. And the y coordinate now, you'd have to go over here, and that will be f of x plus h. Remember, y is simply f of x. Okay? So f of x plus h. And so you look at the little triangle again. This is the run, right? The horizontal difference, which we already know is h. But we also have a vertical difference. And that would give us the slope of the secant line. Now, that's not what we really want. We want the slope of the tangent line. But we can find slopes of secant lines because that's an algebra 1 idea. That's just rise over run. So msec is simply change in y, change in x. And so the change in y is going to be this distance here, the vertical distance. So it's the top y coordinate, f of x plus h. Take away f of x, and the change in the x coordinate is going to be this x value, take away that x value. And I could write that, I suppose, x plus h, take away x. But we already noted that this distance, this increment, is simply h. So yeah, there's nothing wrong with doing that, but notice that x plus h take away x is going to be h, and it's h all the time. So if you just want to write h there, that would be fine. Okay, h, like that. That's the slope of the red secant line. Now what we want, again, is we want the tangent line. So we consider this h getting tinier and tinier and tinier. As h shrinks down, this point travels along the curve, and our secant line gets closer and closer and closer to the tangent line. And when h finally goes away, this point falls right on top of that one, and we have the limiting case where we have our tangent line. So m tan is going to be the limit of this guy right here, f of x plus h. Take away f of x all over h, but now we want the h to go away. H goes to 0. Okay? And that was the second, I'll go back to our quiz, that was the second definition that you have to just be able to write down. F prime of x is this particular limit, limit of the difference quotient. Okay? Now again, the big scheme of things here, the x represents any value in the domain of the function. And then for the first one, the c represents a particular par, P-A-R-T-I-C-U-L-A-R value in the domain. The other thing, again, you don't have to write anything on the quiz Monday except for just the definition. But what you should see in the big picture, let me go back to my notebook page. In the big picture, this works out to be a number, and this works out to be typically a variable function of x. It really depends on what x is. So, and we'll do this on Tuesday. When we do the same quiz on Tuesday, I'm going to give you some stuff like what we had last. Today's Friday, so on what we had on Wednesday, I'll give you that quiz again with other functions in there. You know, as an example, if we had f of x is x squared, and I said, what's f prime? That works out to be 2x. That's that power rule in action. But if I asked what was f prime of 3, that works out to be 6. So again, you see the derivative at a point is a number, and the derivative at any point, the f prime of x, is a function. It depends on x. Okay? So hopefully you watch this a couple of times. You walk in Monday, you get your A+, and you understand what's happening in 12 minutes. They're going to hate